Welcome, guys. So today we keep doing our gamma function introduction. So today we are trying to prove this famous functional relation. And before I start, please subscribe to my channel and click like button and leave the comment below. Okay, so reflection formula is really important in the gamma function. It tells you that the gamma probably is the most important properties among all. Okay, so gamma z times gamma minus z is pi divided by sine pi z. Okay, so this is the formula we want to prove. Okay, so all we need to so in the beginning it seems like all we need to do is just write down the definition of the gamma function and just try to plug all in and see what's going on. Okay, so gamma of z is just 0 to infinity exponential minus t to the z minus dt. Okay, so it's here. So this is gamma 1 minus z, and this is gamma z plus 1. And 1 I use s and t. Okay, so finally you get 0 infinity s divided by t z exponential minus s plus t ds dt. And then we do a change of variable. We just that I already write. I just that u equals to s plus t, and v equals to s divided by t. So it's v to the z exponential minus u, right? So we need to change ds dt into du dv. So we calculate Jacobian. So Jacobian just I think I don't have to write. So basically, I think it's partial u partial s partial u partial t and partial v partial s partial v partial t. And it denotes J inverse. The reason is that since we need to change ds dt to du dv, right? So this formula looks like that J inverse. So we denote J like this, right? So basically J, so basically ds dt need to become this J inverse du dv. Okay, so we put back in, right? So the calculation here show you that the answer is v plus 1 square u du dv. And the region, okay, so let me see the region. So right, because all of it can be 0 to infinity, right? So for the u, right, u is definitely from 0 to infinity. Also v, right, because t can choose t can choose to very close to 0, and s can choose to infinity. Okay, so we got 2, right? Got 2, and this is 2, right? This is 1, and so the final is we just need to calculate this integral. Okay, and this integration can be computed. Just the answer is pi z divided by sine pi z. Yeah. So basically, you need to prove using complex analysis. But okay, so let me quickly prove. So we can let f of z to be maybe z to the a, and z plus 1 square. And we are going to show this. This is correct. 0 to infinity z to the a. Z plus 1 square dz equals to pi a sine pi a. A should be less than, right? Okay, so the quick proof is that you take a contour integral, right? So a b, and so a is basically what we want to compute, right? But b is same as what we need to compute, but z, since it go around, so z need to change it to z times 2 pi I, right? So if you put a minus b, a plus b, right? Basically you get 0 to infinity. I got a little bit quick, but since this is complex analysis result, so we can just directly use. So you get 1 minus exponential 2 pi I a, right? Because this is 2 pi I, right? But there is an a here, okay. Then it becomes 2 pi I residue, right? But there's only one residue, it's minus 1, right? And this is the quadratic. This is the second order, right? So so the residue at z equals to minus 1, z to a, z plus 1 square, right? Then the answer is just 0 to infinity, z to the a dz, z plus 1 square, 1 minus exponential 2 pi I a, 2 pi I a, right? So you need to do a differentiation with respect to za and then put z equals to minus 1 here. Okay, so put minus 1, you need to just write an exponential pi I. Okay, so it's exponential pi I a minus 1. Okay. And I think you just shuffle. Right? You just shuffle. You can fix this term and shuffle these two. Right, and finally you can. Okay, so maybe let me just. So it's a exponential pi I a. 1 minus exponential 2 pi I a. Right, so you can combine you can delete this one, then it's become minus pi I a. This is exponential pi I a. And the denominator is just 2i sine pi a, and it's basically minus 2 pi I. Right. Since this is minus, right there, so there's a additional minus sign here. Right? Okay. So you can take seeing that this all cancel, and I cancel. So you get pi a divided by sine pi a. Okay. So in this case, it's pi z divided by sine pi z, right? So this is pi z divided by sine pi z, and then this gamma z plus 1 is just z gamma of z. So cancel about this z. Finally, we get this. We get gamma z times gamma 1 minus z is equals to pi divided by sine pi z. Okay. Yeah, it's very good that we compute. Okay, I will see you guys in the next video. So next video we will talk about a beta function and other properties. Okay, so be sure to